So strings is Java's way of outputting information to the user. But a string is actually really kind of interesting. It's an object. But it behaves a little bit differently than most other objects in Java. And right now I tell you that, and it really doesn't mean anything because I really haven't introduced any other objects in Java to you yet. So the only reason I'm telling you that now is don't imagine that as we talk about strings that this is going to be indicative of every object in Java. Strings are kind of unique in the way they're handled in Java because they're used so often. So they put some built-in shortcuts that you don't have to deal with certain overhead that usually exists with other objects. But strings are essentially a collection of characters put together. But since it's an object, that means it has what? Characteristics or properties and methods. It has those two things. It's not just a collection of characters. It has the ability to do stuff, which is kind of odd when you think about it, but it has the ability to do stuff. It can contain words, characters, digits, and symbols, and it's always between two quotes. Unless you store it in some type of container. And we'll talk a lot more about those containers as we move forward. So all output and input in Java is done in strings. That is a very important statement. All output and input is done in strings. Java reads your keyboard through something called the keyboard buffer when you type a letter. And it doesn't care whether it's a letter or a number. It treats it all the same. There's something called the ASCII character set. And we actually don't use ASCII character set. We actually use something bigger now, the Unicode set. But the original ASCII character set had 256 some odd characters, which included the alphabet, lowercase, and uppercase. They're treated separately. Digits are separate. Semicolons, special characters that you can't really even get to on your keyboard. They're all treated separately, but they all are treated in terms of comparison the same type of thing. So a capital A and a lowercase a are the same type of thing, but they're treated separately in that they have different values. And we're going to talk more about that when we start talking about individual characters. But for right now, the important part of understanding that is that numbers, when they're inside those quotation marks, are treated exactly the same as letters most of the time. You have to do something specific to get Java to treat those numbers as anything other than just characters. Does that make sense? So you really need to think about numbers as symbols in two different contexts. Either it's a symbol that means let's do some math, or it's a symbol that means it's just a squiggly on a line on a page. So why does Java use strings for input and output? It's just simpler. Instead of having to interpret that the key you pressed on your keyboard is supposed to represent a number, instead of it making that decision for you, it allows the programmer to make those decisions. You're going to hear me saying this a lot through the entire year. Java gives you tons of rope to hang yourself with. Like a lot of it. There are lots of things in Java that it lets you do that you probably should not do. So there's going to be a difference between things that we say, hey, yes, Java allows you to do this. There is a command that will let you do this, but you shouldn't. So there's a difference between coding etiquette, coding style, and actual code that will run. We could take our program from the other day and put it all in one single straight line. It will run without a problem. That's really awful programming style. It does have its uses, though. That's called mimification of a file. When you take all the extra spaces out, it makes the file smaller. So once you've gotten to the file where you know it's going to work and you're ready to compile it, taking out all those spaces, making the file smaller is important. So that's one of the reasons why it exists, the ability to do that. So we talked about print yesterday and println. Order matters. If you do a print, what happens? Correct. The cursor stays on the same line that it was on. It never leaves the line. If you do a println, the ln part is a line feed carriage return. So it does the print and then does a line feed carriage return and brings the cursor down to the next line and back all the way to the left-hand margin. So that's going to make a difference in terms of the order in which you print things. You might want something on a single line. So if you print something here and then do a println, this will all be on the same line, but the carriage return, so print and then a println, the carriage return will be down here underneath the one line. Yeah. Why do they do that? There are times when you want to print text in continuous manners. Let's say you're printing, let's take like a video game. Let's say you're doing like a choose your own adventure game, right? Something like that, where you're printing a bunch of text on the screen. Most computers will word wrap a window, but the resolution is going to be dependent upon the computer. So rather than you dictating where the line breaks are, you allow the computer to dictate where the line breaks are. So you just do a print. However, if you just did a print and just put all the text on one line, it'd be really difficult for you to read. So Java needs the ability to come down to the next line. You can't do a carriage return and come down to the next line and continue the string neatly. So that's one reason why you might want to use a print. Another reason is maybe you want to print something to the user and then print the contents of a variable, and that may be Greek to some of you. But that's another reason why you might want to use a print. Okay? So there's a couple different reasons why they do it. But again, Java does a lot of things that you're going to scratch your head and go, why would they put that in there? And again, they're putting it in there because they want to make it a complete language that has the ability to do anything you want it to. Even if they say it's really silly, they'll let you do it. Okay? Did I answer your question? Okay, fair enough. So, a quick thought. Can you do calculations with strings? Just think about it for a minute. Can you do calculations with strings? All right, so we're going to play a little game here. When you say calculation, what are you thinking? What's your definition of calculation? Math? Addition, subtraction, multiplication, division. Would it be a calculation if I figured out where the middle of the string was? Okay. Would it be a calculation if I counted how many characters were in the string? Right. That's a. So can you do calculations with strings? Yes. Absolutely. Can you do 3 plus 5 inside of a string? Will Java do that? No. If you put 3 plus 5 inside of quotes, it's going to let me do this. Java will not do that. Not at all. Sorry, just won't do it. So you can't do that. But there are calculations you can do with strings. And it's kind of interesting. Java will let you do this, regular math, and then do this. And it'll say 8 answer. So that might, you could argue whether or not it's actually doing a calculation with a string or alongside a string. But this plus sign means something different than this plus sign. These two plus signs mean something different, and we'll talk more about that later. They mean different things. Okay, good. So by the way, I'm going to pause the recorder. You can play the video in Blackboard. But by the way, there is a origin to the term computer bug. The phrase computer bug actually comes from somewhere.